Hello, everybody. I hopefully have pushed all the right buttons and we are now live. So shout in Discord if we're not. Or I guess shout in Discord if we are, because if we're not, then you won't hear me asking you to shout in Discord.
Mic check from my side.
Yep.
Should be there.
I see a bunch of people typing, which I assume, yes, people can hear me. They're not asking where I am. Great. I'm Jeremy, and I have a beard that is far too big and has far too much grey in it for this particular talk. But I volunteered to chair this session because I thoroughly look forward to David's talks on this and related topics at every conference he speaks at. And I'm sure this will be no exception. David, according to his bio, which I have here somewhere, is all about helping technology and humanity work together in Africa for Africa, which is certainly excellent life goals. And then there's a bunch of other stuff about what he does for a living and code and helping kids and that kind of thing. But you're not here for that. You're here for the loop of joy, helping kids and grown-ups enjoy code adventures. And I think I've spent more than enough time waffling on about this intro stuff. So I shall hand over to David. Take it away, sir.
Cool. Thanks, Jeremy. And hi, everybody. 3:45, end of a long day. Going to try to keep energy up. I hope you've had coffee like I did. Just had a quick coffee game session with the team to try to wake myself up. So today I'm going to talk about this thing, the loop of joy. I spoke about it in PyConZA 19 with Whitney. We had a picture there of a GIF of an in-person dojo. This picture is a remote dojo using Gather, which we'll be doing. Actually, PyCon social event will happen in Gather. Kids are completely crazy in Gather. But yeah, I'm here to talk about this thing called the loop of joy and how it keeps us engaged, alive. Firstly, we need to get the next slide. There we go. No, don't do two for me. Okay, so I'm David Campey. I started to realize that what I do is probably best called enjoy-engineering, helping us enjoy engineering. Somewhere in the 80s and 90s, I was learning to code and going to school, probably in that order of priority. About 2004, I started a company that today is AfroLabs. Happy and delighted to sponsor today. 2012, we sponsored our first PyCon, I think was 2012, and I met a kid called Sam there who was very much like me at age 11, had figured out a bunch about coding and was stuck, and he'd managed to get to PyCon. And so I said, well, why don't you come to our office and I'll help you. And I ended up starting a club and then joining the CoderDojo movement. And then a couple of years later, in 2018, we started Coder Level Up as a not-for-profit to wrap up the various things we were doing with kids and professionals and startups. And this year, the global group is celebrating 10 years of CoderDojo, and we're about 9 into ours. So things have grown. As Jeremy said, I do a bunch of other things, but today is really about the loop of joy and kids and coding. On the right-hand side at the top, you can see a slightly older picture of my youngest daughter making some stickers in Scratch Junior. My oldest daughter connecting some LEDs with an ESP32 that I got as a speaker gift from a previous PyCon. And Kyle, who's almost like a half brother to my kid, so is a lady who works for our son, and that was him having a certificate after having sent his Python code to run on the space station. You can see a little peg where it ran in Australia. The stuff is super exciting and it keeps us going. And today I'm going to talk about like how we do it. Our organization, just for context, is called Coder Level Up. We're a regional growth partner of a foundation called the Raspberry Pi. You've almost definitely heard of these little credit card sized computers that are sold around the world. What you might not know is that all the profits from that go into supporting the growth of coding and getting people into computing. And there's two organizations, CoderDojo and Code Club, that the Raspberry Pi Foundation supports. There are exactly 2,378 registered dojos and about 30,000 code clubs globally. And in South Africa, there are 12 dojos and 88 clubs. And as a growth partner, we help connect people to resources to start their clubs, connect them to all the open source goodness and training materials to get clubs going. Our sponsors, just a quick hat tip to them, AfroLabs does most of the sponsorship. We've received some sponsorship via Google from previous employees who now work at Google who've used their Google donations, but more sponsors always welcome. Ask us if you can give us money. Okay, that's not the way. What do we actually teach? So this is one of the best questions that has a hard answer, because as HTML, Java, JavaScript, CSS, Python, one would hope we teach them Python and Scratch, but like, if I'm teaching kids Python, I quickly lose them. And what we really know is if I'm teaching anyone anything, you become a teacher, and anybody who's learned to code, it's very hard to be taught. It's hard and it's challenging, and you have to really get into it and you have to connect to it and start enjoying it and get passionate about it. So what I realized when I was trying to help mentors understand what it was when we were doing coding classes and education is we were helping kids learn to code by teaching them that there's this loop of joy in their work. And so for the mentors, my goal was to say, okay, let's connect this loop of joy. Take whoever you're educating and say, okay, let's have an idea. What would you like to try to do? I can show you some things. Which one would you like? And then you're going to try, and it's going to be hard. And then you're going to see it working. And then you'll be like, can I take the next step? So that loop of joy is something that's become central in my work with professionals and kids and startups and everything pretty much. So with kids, even before they can read, we can have this idea of the loop of joy where I'm using a platform like Scratch Junior, can have an idea. Maybe I want to add an extra butterfly to my screen, grab it from the palette, put it down. I might want to make it hop around a little bit. And start to have ideas of what I can do and keep experimenting around the loop. And then might do the same thing in Sploder, which is a game drawing platform where you can make a game and put the walls too high or too low or too many monsters or not enough health bars. And like the struggle, playing with it working, keep going. Then do the same thing in Unity 3D. Do some C# code, build a level, figure out where you need to put things. Oh, my ball fell off the map. That's weird. We still go through having an idea, finding the challenge, and then it working. And then there's a fun game we like to play called Code Combat, which uses Python code to get a hero through a dungeon. But again, the key thing is that you want to get the hero through. You have the struggle. The hero dies a few times, gets eaten by monsters, and the orcs bash them up. But then you get to the point where it works. So this is quite interesting. And I formulated this for kids. And then when I got to work and I was like, wow, everybody's sitting in the struggle. We're sitting in this bottom right corner making a thing. And then someone, like we almost design our organization. Someone makes a decision, someone else makes the thing, and someone else takes it to the customer. So we've got sort of a product function, a development function, and a customer engagement function. And by separating them, that loop of joy gets disconnected. And much of my coaching work these days is to think about talking to the people who make things, trying to get across to how can we make it more visible and how can we make decisions, and chatting to people in the other boxes and saying, how can you spread? Because as we crank that handle of the loop of joy, this is the learning. It's, if you remember one of those old-time cars, right? That handle on the front, you crank it once, you crank it twice. Once that engine's going, then I can make something else. What am I going to do? How am I going to get going? You've got this sort of underlying faith that turns the thought or the desire from, so without that faith, the desire is kind of despair. With that faith, the desire can become hope. And then you can hopefully engage and just enjoy making. But like, right, okay, I've gone so meta here, all the way out, and one should show, not tell. So what do I mean about the loop of joy? And let's start right at the beginning in a Python shell. So there's an assumption here that the person that we're helping learn to code can read. By 8 or 9, this is a good exercise. 6 and 7, this is a bit of a challenge. 5, don't try it. So that's kind of some age guidance for this. But if they're at that age where they're starting to do numbers and maths, the first thing you might do is this 1 plus 1 up the top, and then 2 comes out, and then 5 plus 8, 13. Now, this isn't a very accurate example, because by the time a kid figures out that they can add 2 numbers together, they'll spend the next 10 to 15 minutes adding short numbers and longer numbers. They don't quite go as far as this. But then you get these cool red errors, or something's broken, and then they'd normally leave if there wasn't someone like a mentor around to be like, okay, we can get through this struggle. I can help you understand what all that red weirdness is. And then it works again, and your loop of joy gets stronger. And then you might have letters in it. So very, very, like, in terms of where to start and how to start in Python and get that loop of joy going, I haven't told anybody about a variable or anything. I just asked, like, let's see if the computer knows 1 plus 1. And the fascinating thing, for most people in this talk, when you grew up, you had calculators about you. For most of the kids that I'm helping to learn to code, calculators aren't a thing. So this is like one of the first times they've seen that computers can do magical things and add numbers together. And then we'll ask, say, does the computer know your name? And type in name. And you get this thing that says name, error, name is not defined. It says name a lot, actually. It's quite funny. And then you can tell it your name. You might notice that I write my name with a colon before the D. It distinguishes me from the extremely large number of other Davids out there. And it's one of those joyful smiley faces. So it's not a typo. And then you say, what happens when you say name times 10? And you can get it a few times. But before that, you'd ask, what would happen if you times your name by 10? And that's like a not question. It doesn't mean anything. You can't times my name by 10, but you can. And then name times 100. Now, this is when the curious inquiring mind goes, what if I do names times a much bigger number? And you say, well, try. And I'm sure you're tempted to know the answer. So if you take 9 times a bit of a bigger number, it just like fills the screen with tons of text and like, oh my goodness. And then many times the laptops that your learners are working on can't quite keep up with this, and things start to crash, and they've crashed the computer, and everyone has to come around and see it and want to know how they can crash the computer too, and generate these huge, massive walls of text, and then wonder what else they could do. In the interest of not killing my Chrome, I'm probably going to try to stop this now. Yay, I was able to interrupt it. So then the loop of joy moves along, and not going too fast, right? So we crank that handle on the number thing, and then they come back again, and you'll do that again. And we start to build trust and fluency in it. But then there's like this fun thing called Python Turtle that I would like to show you now as an example. So we may know that Python has batteries included, and one of those batteries is the turtle module. So you can literally say import turtle, and then you can go then equals turtle.screen, and then a magic thing happens. You've now opened a window with code, which is also pretty amazing. There's nothing in there, so let's make a new little turtle. And then we got one, and then let's get Tim to go forwards. Oh, this, if you've seen this, oh, I've just made a mistake. Oh no, what's wrong? And they might sit for a while and go and ask a friend, and then find out that the computer really cares about the difference between forward and forwards. And then we're going to put in left. So I'll generally show them these first few steps, and then if you're looking at the picture on the right, your little lip of joy is probably going the same way that most little lips of joy go, and go, oh, could I make a square? I was like, I don't know, can you? Sure enough, I'm not going to leave you hanging there. You make a square. And ta-da, it's closed. Now, as adults, we'll probably move on quite quickly. But my experience is that some kids will say, well, can I draw a person now? Or can I draw a town? Or those are nice blocks. Of course, you can try. And they'll sit there laboring away, practicing and really getting to know where the dot goes and where the brackets goes, and make all these mistakes. And ultimately, little Timmy gets super happy if he can type and talk at the same time. He can do a little dance, but that's not a turtle. What are you talking about there, David? It changes shape, giant wall of red text. Red text is quite exciting depending on if you make it a bad thing or a good thing. You can actually make it look like a turtle, which satisfies a few people. It doesn't satisfy certain people who say it looks like a tortoise, and then you can get into a Wikipedia debate on what a turtle is or a tortoise, and I'll leave that as an exercise to the reader because it's a bit depressing. But there we go. We got a happy turtle doing a happy turtle dance. Maybe it's his own little loop of joy right there. Okay, so we've seen this turtle having this idea, going through a couple of failing moments, getting it to work, turtle being super happy. Now, by this point, someone's loop of joy is connected, and they say, well, what could I do next? I'm going to show you something totally amazing. I get to make dad jokes, firstly, because I'm a dad, and secondly, because it's not even my joke. It is, in fact, legitimately totally amazing. So totally amazing follows steps that you might have seen 2 seconds ago, but using Trinket in the browser. So there's less install-y stuff, which is both awesomer and less awesome. It's quite pretty cool to have it running on the computer and be able to do on my machine code stuff. It's pretty cool to be able to have pre-built code examples and run through them in the browser and share your code. But the cool thing is you can do it in both places, and you can be hardcore at the console, and you can use idle, and you can use Trinket. And I've just showed you all 3 of those. And then you kind of, so this loop of joy starts with looking at this fantastic picture and wondering what it is. We go through these, drawing a line and turning. It's like an afternoon of playing with it, changing colors, repetition, spirals. You might spend an afternoon on 1 or 2 of these at a time, and eventually you put it all together in this magical moment of you got this beautiful thing with colors appending and with colors and moving through them, and you can twiddle these numbers and make the picture different. It's just pretty totally amazing. I'm going to hop on here. So as you go through this, it breaks a lot, and the Trinket code moves quite fast, and it does require someone tutoring to go back and say, okay, look, it said turning, we've done some basic things, let's read what it asked us to do here, complete the square shape. But the nice thing is there are these cool step-by-step instructions, and if you've got completionists out there, they can completely tick boxes and move along. There are tick boxes on many of the activities. Now, you're also probably wondering about all of this Chrome around here and the Raspberry Pi logo. I'm not going to tell you about that now. I'm going to go meta for a moment, and then I'll come back and tell you about all of that. So for this meta moment, there's this dude called Seymour Papat, who was South African, went to Wits, popped to Geneva for a while, met Piaget, and understood constructivism, which is the idea that we build our own mental models as part of learning. And then invented Turtle, right? And it was pretty cool because Turtle was actually where I did my first coding education, formal coding education. When I got to school and I needed to do something on computers at school, someone taught me Turtle. And I didn't know it was made by a South African until recently. Now, his protege was Mitch Resnick, who now holds the title of the Lego Papert Professor at MIT in the lifelong kindergarten lab, where we're trying to take these kindergarten concepts of learning, and in this learning creative learning course, take those concepts into education at all levels and work. And he's also the creator of Scratch. So I'll leave Scratch hanging for a second. As a part of learning creative learning, there's this creative learning spiral, this concept that we imagine, we create, we play with what we've created, we share it with other people, we reflect on what we've made, and that feeds us imagining more. If that looks like the loop of joy, it's not an accident. It is an accident that they both go the same direction. But it's not an accident that they follow a similar process. The idea with this one is that it spiral outwards. I really like that. I drew it first as a loop of joy, but it connected with both. And I've done the Learning Creative Learning course twice, and it's available free online whenever it runs. Out of MIT, there's all time zones, and the groups can run that. And part of the idea from Learning Creative Learning is that there are some foundational elements. If we can structure our work in projects, find things that we're passionate about to work on, so we actually engage with them, do them in a playful way, and have peers to share it with, magic can happen. So, to show you a demo, I am going to show you some Python in Scratch. Now, that's a bit of a lie because, well, firstly, I've lost my entire project. So what I'm going to show you instead, it was a joke. Anyway, you don't actually get to do Python in Scratch, but what you can do is find the snake. I did prepare this earlier, but unfortunately I've lost it. So you have to bear with me while I nuke this guy and take this little snake, and I'm going to full screen this. Yeah, okay. Hello, snake. There is a snake, and he's on the screen. And for now, what he's going to do is I'm just going to say, when I click the green flag, please say hello to all the good people out there at PyCon. I think that's going to be enough for today. Maybe not. Hello, PyCon, and I'm going to click the green flag, and it says hello, PyCon. Now, the fun thing about Scratch is that it follows the Learning Creative Learning concepts of low floor, high ceiling, and wide walls, meaning there's not a lot I need to get in to do something in Scratch. And in the beginning, maybe I'll just browse through all the stickers and make a cool sticker scene and just keep going. And that's cool. But then I might want to make it say something. I might want to add in a loop to make it move a bit. And the thing is that these things, motion, please, motion block. The cool thing is that my brain is not completely connected. Zwink, we go there, and oh dear, he's gone too far. I have to keep moving him back. And then I ask someone for help, and they tell me drag to where you want and put a go to XY block in at the beginning of your program, and he goes there. And he's saying hello to PyCon. All the nice PyCon people say hello back in the chat. I mentioned high ceilings, right? So you can import a module in Scratch that lets you make a little Scratch. This is a little piece of Scratch code here running, where when you hold up a piece of colored paper, it counts the number of creatures you've had, and you can fold those as origami creatures and do this project. And this project is quite cool, and it forms part of the Protect Our Planet pathway, which I'll get to in a moment. So let's hop back to our presentation now. No, come back, please. Thank you. And we had this challenge, right? CoderDojos were these wonderful in-person places where we used to help kids through the loop of joy. And then a pandemic happened. So we couldn't really meet in person. We were meeting remotely, and we were trying kind of hard to help kids through things when you can't sit next to them and their communication levels are challenged at a distance. So one of the awesome things that's come out of it is that there are these learning pathways of collections of projects that have been put together to help choose appropriate exercises, like starting at a level. The first three are generally relatively straightforward, and then they get harder. You'll see count the creatures in there. And I've shared two pathways here, the one from Scratch and the one from Python. They're both from the projects that Raspberry Pi site. And as I promised, I will just give you a quick peek in at the site. So the actually totally amazing part of the totally amazing demo was that if you head over to projects.raspberrypi.org, you can say, I'm really interested in doing a Python project at level 1 or level 4, where 1 is the starting level. And then you can hop down here and say, oh, I'm interested in making a role-playing game. That'll be fun. And you click in there, and you've got a tutorial that's been made by someone in those 2,300 clubs or 2,300 dojos or 30,000 clubs who've played this a number of times with kids, and you could start making something fun. Some of you probably want to go and make that right now, and you can, because it's free and open and there's no logins or anything. The sign-in is just track what you've been doing. Similarly, you can filter for hardware and all sorts of stuff. And since the Raspberry Pi Foundation adopted Code Club and CoderDojo, you can filter by exercises that came out of those. Or you could just go for anything you like, really. So, that mouse wheel was too hardcore. Keyboard. So we start where kids are is the question. So we need to say, I'd like to maybe do some Scratch and Python with you, but where are you? One of my suggestions is always to play. So let's play some games to discover where our learners are. It doesn't really matter how old you are. Lightbot is a super fun game to start with that until Flash disappeared was pretty accessible. Now slightly less accessible and just working on ways of getting everybody to play Lightbot. But if you can see by the little Lightbot screen in the bottom corner there, not much text, and you can sort of see if someone's comfortable with a mouse and a keyboard, and it's a facilitated game to play through. And then if they're sort of good at reading, you can move into Code Combat, which I showed earlier, and or code.org, then move towards those Python turtle exercises, and then move towards Scratch. And then you can hit these pathways. So, okay, I've got some basics of Scratch. Here's a whole set of projects you can do. And the cool thing with the project pathways is that the foundation has made some printable certificates to put at the end, which is really important in keeping our own motivation. So the next question is, where would you actually find kids physically or bring them together? Of course, with COVID, it's a challenge, but head over to CoderDojo.com, hit find a dojo or start a dojo. If you find a dojo, you might find one near you that actually needs help getting going again. And if you don't find one, hit start a dojo, and there's a whole bunch of course material on how to get going. You can register a dojo without a venue and then try to find a venue. And then you'll probably get in touch with me because I'm a regional growth partner. So at some point, I'll probably help you get going. And in all of this, what I've learned in the last year or two, helping mentors help kids, is that your own loop of joy as a mentor or as someone helping kids learn to code, or even as a professional developer, is probably the most important thing. So if we think about mentors in clubs, what we've realized is that having a framework to help you imagine what you might do next and try projects and decide to help kids and learn creative learning is an ongoing process. We need to keep imagining and re-engaging there. Then making something with someone, helping someone make something, is this very, very iterative process. Dream big, start small, but actually start. And the magic, at least in the mentor space, comes in making it visible. And that's where things like the pathways help you make another decision, but they also help you notice the progress that the ninjas are making, or we used to call them ninjas, now the makers, are making through the process. And when you're in person, you can see that. When you're remote, it's sometimes not clear. So being able to have these pathways and see that they finished them and then give them certificates has been great. Last year, we ran the first Coolest Projects in South Africa. Coolest Projects is a technology fair for young people where we showcase projects made by kids with the main goal of blowing adults' minds and showcasing what the kids do. And we had an international judging panel and some cool submissions, and the mentors were super happy and the kids were happy, and it amplified everything. And as I mentioned in the beginning, there's also really fun things like AstroPi, where you get to send code off to the International Space Station and write Python code. Now, because of reasons, that's sponsored by the European Space Agency, so we've had to create an international collaboration where kids from non-EU countries pair with kids from EU countries, merge their code, like write code separately, merge it together, submit it, it gets sent to the space station. Last year, we collaborated with Germany. This year, it's Iraq, Israel, Germany, Greece, South Africa. It's pretty amazing the things these kids are doing and having fun. And that, for me, kindles my loop of joy. Wow, what could we do next? So I invite everybody in the room to think about what might get your loop of joy going on making with kids. or making something new for yourself, or maybe making work visible and making decisions at work. It's everywhere, and joy is what's going to keep us going. And that's me. I think I'm open to questions. Having a look to see if any have come up. I'm going to pop my eyes down into the Discord now, and Jeremy can help me if he can, being a noob. I'm now having the struggle moment where I might get joy on the other side.
We don't have any questions yet, so please type them into Discord if you have any. But a comment from Karika, whose name I hope I've pronounced reasonably correctly. So excited about this session, all the good feels, which is a large part of why I enjoy David's talks every time.
Well, yes, hopefully those good feels are also a bit like that, connecting the battery on the jump starter on your loop of joy that can get enough of the good feels going that stuff will happen. So yes, I mean, this someone mentioned the crack dealer thing. Yeah, you get to the point where you can't stop people learning, and that's really what happens. And helping through the frustration and not giving up is super important. Plus screen time is an interesting thing. Just while I'm waiting on a question, I generally encourage parents to say, rather give like double screen time if you're making versus if you're just consuming. So let's create a generation of creators, not consumers. That makes a cool shift. And then, oh, you mean I could be sitting modeling? The kids love doing some 3D modeling or making games, playing games. And I turn a blind eye if you're playing a game that you made. Sure. What are usually called hoops? What was that?
My early experience was discovering that making games is more fun than playing the games I had available to play. That's what got me hooked.
It's fascinating. Yeah.
Okay.
What happens?
We have some questions coming in. Question from Fuad. A shout out to my son Khalid for watching this awesome presentation with me. So,
hello, Khalid. And how old is Khalid would be an awesome follow-up question. And if Khalid is already coding, I'd love to see stuff. And if not, I'd love to help Khalid. Johan Bayers asked a question about physical electronics projects sparking the same loop for the same people. I love electronics projects a lot. I don't have in my mind an idea that there's certain types of people that do things, but when you plug an LED in and it makes light, that's pretty fun. I don't know what I've got here in my office. So, I mean, there's these little adapter boards for the microbits. So the microbit is a fun board. So the microbit is quite a nice bridge board from BBC that you can program these LEDs via dropping a flash file onto it. You program it with Python or a block programming language or something like that. And then you can run it just with a battery pack and carry it around and make little LED-based games. And just knowing that that's an entire little computational thing is super cool to play with. Saw in the intro the picture of my daughter's pizza. It wasn't actually a pizza box. It was a clock box that my single-handed clock came all the way from Germany in, that she stuck LEDs into the top of and made stuff do. Yeah. So Mark, I'm just going to read these discords while we're going. Forward. Okay, we got that. So the bot is just confusing me a bit. Consider playing Minecraft to be consuming or making. Generally, my guidance for ninjas at an in-person dojo is, if you are here and the thing you're doing, none of your peers could help you with, and I couldn't help you with, so it's not something that you're struggling at, that this time here would help you make progress with, like, you know, having to figure things out, then your mom or dad's probably not going to justify bringing you back again, because you didn't really change anything in your learning. So maybe you won't get to come back. So perhaps try something else. That's generally what I do, especially if they start playing tank games and stuff like that. I'm like, I can't really help you with that. You're welcome to do it, but it's going to self-select you out of coming back. I'm quite rational with them there. And so similarly, playing, I don't know. I don't have a clear answer, especially on Minecraft. Richard Lander's question, how would you apply to adults wanting to learn to code? Now, that's a good one, because adults are complicated. We want to do clever stuff. There is, I'm not going to hop back, but there are some cool things out there, like Automate the Boring Stuff with Python. Is a nice book that makes it feel like you're doing things. Code Combat is also fun because you're doing things. The problem is grown-ups want to be too big on the top of the loop of joy. Like, I want to do something really big. So when you get to doing it, it's too hard and you never get around to seeing it. So some of it is trying to encourage building a fluency of playfulness. Of, I want to make and see and make and see and make and see. So that's what I try to encourage. And there is a website called Hour of Code, which generally, if you can't get something interesting off of Hour of Code, I don't want to say anything too disparaging. So Hour of Code started as this 1-hour introduction to computer science. Look at me just reading their website. But what's ended up happening is so many people have been wanting to be part of serving this 1.2 billion people around the world, that there's this library of activities from everybody involved in coding education. And you can find something for everyone. So I would generally encourage, like, find an hour of code activity that you would be interested in here as an adult, do it. And most of these are designed to be able to be finishable in an hour, and then have a conversation with a computer scientist about, okay, well, how does that actually become a thing?
Maybe it will help if I jump in and ask the questions while I put them up.
Yeah, let's go.
So question from Rudy.
Yep.
Yeah. Do you know any good resources for people who want to learn coding later in life?
Yes. So as I mentioned earlier, our not-for-profit focuses on kids, professionals, and getting into the professional space, as well as startups. So I know quite a few of them. My most correct answer is it depends. Firstly, have a look to learn about all sorts of coding at Hour of Code would be a good place to start and sort of open your eyes to what coding is. If you really want to get into front-end dev, Free Code Camp is great. They have a full stack cert that you can do, but it's hard. Like, it's going to take a lot of grind, so you have to be super committed. I also suggest resources like Automate the Boring Stuff, as I mentioned earlier, because it feels like you're doing something, and it connects that loop of joy. So Automate the Boring Stuff is available for free online or purchasable in the way of many things. And you do fun things like web scraping, Excel spreadsheets, PDFs and CSVs, and time scheduling. Do we have another one there, Jeremy? Yes. I generally suggest that as a start. So, that's like, just to summarize, crank the handle once or twice and then say what next, rather than setting yourself a super mega curriculum. Cool.
So, related question from Chris: do you think the larger goal you're working towards is necessary for adults, since we stop exploring quicker?
So there's this little story that I like to tell about the 3 boys crossing the field. But basically, the first one ends up they want to walk a straight line. The one ends up randomly. The other one picks a tree on the other side and tries to walk towards it and has this wavy path that ends up there. And the third one walks a straight path, and they say, how did you do that? He said, I put a bigger tree behind that tree. Now, from a goal setting perspective, having something in mind definitely helps you keep on it. and the dopamine keeps dripping away. If you can see it here, I'm actually chipping away towards a bigger goal. So yeah, adults are more complicated. So setting up some sort of thing behind it is important, but adults will also scroll Twitter for ages, just getting the right little loop hacking. So have something fun to do and start being coding is really interesting. I'm seeing lots of questions. Jeremy, do you want to cherry pick some for me?
Yeah, so a comment from Fouad. Kelly7 started tinkering with Scratch recently. Would you share some of those awesome links you presented, please?
Yes, I'll put everything. I'll put the presentation up where I've got everything in. If you need one takeaway, go to projectsraspberrypi.org and you'll find most things there. Also shared this book, which was actually last off updated by Peter Wentworth from Rhodes, How to Think Like a Computer Scientist, which I'd recommend for a grown-up to read and then think about helping a kid. And there's what I showed earlier, the shell examples, and then the turtles is essentially the précis of chapter 1, 2, and 3. The rest of this, I leave for a lot later, but that's my approach. I like to get a lot of time making before I make sense, if that makes sense. Cool.
Yeah. And then the other question has been asked at a number of lengths, all of them a little bit too long. So I've copy-pasted it here. So from Rohan, I've tried to get my kids to code in Python terminal, but they lose interest very quickly. They've done the Scratch stuff, but I want them to actually write code. How do I get them to stay interested?
So a longer answer might be, for example, the learning creative learning content, and if they're really interested in that and helping others. The shorter answer would be yes. Python starts to introduce brackets and dots, and it doesn't feel like you're making as much as soon. Try Code Combat. If you want, I can share my class code, which gets you the first 20 courses in a different progression, because the free one keeps offering you freemium buy-ins. Also, this Python pathway is quite cool. The second one quickly circumvents all the BS that normally annoys people about Python, and then you end up making a little target practice game. I don't know what's happening with my browser, but there you go, with the dot, and it randomly puts it, and it's all about getting a nice visible result and closing the loop of joy, and eventually that random's going to hit that target and we're going to win this game. But while we wait for that, someone else's question.
So we're a bit short on time, so this probably good for this would be the last one. So question from Sia Balela: would doing turtle on top of Flask be overkill?
Never. Like, nothing is ever overkill if someone really wants to do it, right? I'm not entirely sure how you would do that or why, but the cool thing with kids is that the why doesn't have to make sense. You could make a zombie with a pumpkin on its head, and that could be fun, and it could run around and amuse you. So if you want to figure out a way of coupling those two together, play with the individual parts, satisfy your itch, and then if it's like, wow, could I make that get going? Try. And if you can get a mentor or someone to help you try through, then and it works, it'll be phenomenally weird and interesting, and you might be happy. You might not, but yeah. I think that's the thing. Let's crank that loop, get through the struggle, and get to the joy, and that's what's going to keep us going.
And that's the end of our time. So thank you very much. And I have some applause here, which I'm sure everybody is enthusiastically giving you behind their muted microphone.
I will hop across to, I don't actually have like a contact me slide, but at David Campey on Twitter or anywhere that will work. And I'll share everything in the Discord. So actually the Discord is going to be the bridge. See you there.
Cool. Thank you very much.
Cheers. Thanks all.